Hi listeners, welcome to the video lecture series on power electronics. In the previous video, we have discussed about the symbol, construction and principle of operation of power MOSFET. Also, we have seen the transfer and output characteristics. In transfer characteristics, we have fixed the values of VDS and we varied the VGS and we plotted VGS and ID, that is the drain current. And in that, we understood that there is a voltage called as VGST, that is gate to source threshold voltage, above which the device turns on, which means that the drain current increases very rapidly above VGST. In the case of output characteristics, we fixed the values of VGS, we varied VDD, we observed VDS and plotted against ID. And during this output characteristics, we come across three regions of operation. One is the cutoff region where the device is completely off, and the next one is the ohmic region where the device has linear relationship between VDS and ID. And the third region is what we call it as the saturation region, where the device current, either is drain current, is constant or saturated. So these three modes of operation or three regions of operation is what it is discussed in output characteristics. This transfer and output characteristics are also called as static characteristics because these characteristics are used to analyze the steady state behavior of a power MOSFET. But in order to analyze the dynamic behavior of power MOSFET, we need to understand the switching characteristics of it. In this video, we are going to cover the switching characteristics of power MOSFET. Let us go into the lecture. In this video, we will understand the switching characteristics of power MOSFET, and also we will look into the comparison between power MOSFET and power BJT. For further reading, you can follow the textbook of P.S. Pimra, Power Electronics. The corresponding page number for further reference is 20 to 24. The contents of presentation goes like this. Initially, we will discuss the switching characteristics of power MOSFET, and then finally we will have a small comparison between power MOSFET and power BJT. The switching characteristics of power MOSFET is given here. The gate voltage VG is applied for a duration of T1, 0 to T1. At T1, we remove the gate pulse. And VGS is the gate to source voltage with respect to this VG, and ID is the drain current with respect to the characteristics of VGS. The switching characteristics of power MOSFET are influenced to a large extent by their internal capacitance of the device and the internal impedance of the gate drive circuit. At turn on, there is an initial turn on delay TDN, during which the internal capacitance of the device gets charged to a value called VGST, that is the gate to source threshold voltage. This TDN is called as turn on delay. During this turn on delay, the voltage VGS rises from 0 to VGST. Internal capacitance also gets charges to this value VGST. And followed by, there is another time called as rise time. During this instant, the voltage rises from VGST to a voltage level called VGSP. This voltage VGSP is the voltage which is required to turn on or to make the MOSFET to move into on state. So this is the voltage which is moved from during the time TR, the voltage is moved from VGST to VGSP. So during this instant of time, if you look at the drain current rises from 0 to its maximum value ID. So the device has started its on process at this point of time and it has completely turned on at this point of time. So turn on of the device is the sum of turn on delay plus rise time. So after this VGSP, the device goes to a value, the VGS voltage goes to a value which is equal to the gate voltage V1. So this is the turn on process. At time T1, the pulse to the gate is removed which means that at this point of time T1, the turn off process has started. So during this process of time, the TDF, during this instant TDF time, that is the voltage from V1 has come down to a voltage of VGSP. So this is the voltage which makes the thyristor to move into on state, MOSFET to move into on state. So this voltage is coming from V1 to VGSP, and that duration is what you call it as turn off delay, TDF. And from VGSP, again the voltage comes to a value of VGSP, and that time duration is what we call it as fall time. And by that time, if you look at the drain current has also come to a value of 0. So at this point of time, at the end of TF, the device has completely turned off. So the turn off time of the device is given by turn off delay plus fall time. During the fall time, the voltage comes from VGSP to VGST. Remember that VGSP is a voltage sufficient to drive the MOSFET into its on state. Hence, when VGS is less than VGST, if you look at this duration, VGS is less than VGST and this duration, the device current is 0, which means that the device is completely in off condition when VGS is less than VGST. So this is what all about the switching characteristics of power MOSFET. Very important to remember, these devices are not ideal devices. That is why it is taking some time to move into its on condition, and it takes again some time to move from on condition to off condition. So this is what all about the switching characteristics of power MOSFET. Now let us move on to the comparison between power MOSFET and BJT. Power MOSFET have lower switching losses, but its on-state resistance is high and so conduction losses are more. Whereas power BJT, switching losses are higher but it has lower conduction losses. These two are contradictory to each other. One, in the case of power MOSFET, switching losses is less, conduction losses are more. BJT, switching losses are higher, conduction losses are lower. And power MOSFET is used especially in high frequency applications, especially when we want to operate the device, when we want to operate the circuit more than 30 kHz. BJT is used in low frequency applications between 10 to 30 kHz. So power MOSFET, if you look at, it is mostly employed in or mostly used in switched mode power supplies. BJT, it is used in some of the high power driving systems. And if you look at power MOSFET, it is a voltage controlled device, whereas BJT is a current controlled device. And the very important point in the case of power MOSFET is it has positive temperature coefficient for resistance. This power MOSFET is having the positive temperature coefficient for resistance. This makes parallel operation very easy. If a power MOSFET shares increased current initially in parallel operation, for example, it heats up faster. The MOSFET during its parallel operation, when one of the MOSFET is initially taking more current, that MOSFET will heat up much faster. So because of it, positive temperature coefficient, the MOSFET which is taking more current will heat up more and its resistance will also increase, and this in turn it reduces the current which is taking by it solely. The balancing of current will take place in the case of parallel operation, in the case of power MOSFET. Whereas in the case of BJT, negative temperature coefficient for resistance, so this advantage is not there in the case of BJT. Hence, they require some sort of current sharing resistance when they are operated in parallel. Here in power MOSFET, no such requirement. It can be easily operated without using any additional component in case of parallel operation. In the case of power MOSFET, secondary breakdown does not occur, whereas in the case of BJT, secondary breakdown occurs because collector current is dependent on base current Hence, the junction temperature increases. This junction temperature will lead to secondary breakdown. So, power MOSFET can be used in application especially where high frequency of operation is needed, and BJT can be used in application especially where low frequency of operation is demanded. And if you look at, there are more advantages in the case of power MOSFET when compared with BJT. It is an voltage control device, whereas BJT is a current control device. That is why in recent applications, many are moving into the power MOSFET instead of power BJT. That's all about this lecture. And in this lecture, we have understood the switching characteristics of power MOSFET, where there is a turn on delay and rise time, which constitutes the on process of the power MOSFET, and turn off delay and fall time, which constitutes the off process of the power MOSFET. And we have compared the power MOSFET with power BJT, and we understood that power MOSFET can be used in high frequency operations, whereas power BJT can be used in low frequency of operations. That's all about this lecture, and in next lecture we will discuss about the construction and the principle of operation of the new device or the next device called as IGBT. Thank you for your patient listening. Thank you.